Hi everybody, welcome to this video on slope. This is a topic you learned last year in Algebra 1, so this is going to be a quick refresher video for those of you who need it. Let's recall that a rate of change is a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. So you'll often see something written as change in y over change in x. There's many real-world examples of rate of change. So some popular examples are population increase. So how much does a population increase over some period of time? Another common example is speed, or how fast a car travels or a bike travels or how fast a person walks. It's an increase in miles for some certain amount of time. So for example, a car's speed being 60 miles an hour, saying that in 1 hour you're traveling 60 miles. So your change in distance is 60 miles, your change in time is 1 hour. A rate of change is constant for a function when the rate of change is the same between any pair of points on the graph of the function. So if you look at this line graphed over here to the right, the rate of change between any 2 points, so as we go from one point up and over to the next point, up and over to the next point, up and over to the next point, if that rate of change is the same between any 2 points, the rate of change is constant for that function. When we're talking about lines that are graphed on a coordinate plane, rate of change, another word for that is slope. The slope of a non-vertical line is the ratio of the change in the y-coordinate, we call that the rise, to the change in the x-coordinate, we call that the run, as you move from one point to another. Okay, slope is represented by the letter m. You'll often see it is written slope equals rise over run. When you have two coordinates that are x1, y1, and x2, y2, the change in the y-coordinates can be represented as y2 minus y1 or y1 minus y2, and the change in the x-coordinates is x2 minus x1 or x1 minus x2. You just want to make sure that whichever y-coordinate you start with in your numerator, you start with the x-coordinate from that same point in the denominator. Lines that are parallel have the same slope, so two parallel lines will never intersect, they have the same slope. And lines that are perpendicular have opposite reciprocal slopes. So opposite is the opposite sign. So if one line has a positive slope, a perpendicular line to that will have a negative slope, and vice versa. Reciprocal is the flipped version of the fraction. So if one line has a slope of 1/2, a perpendicular line will have a slope of -2. Any vertical and horizontal line are perpendicular. So the slope of a line can be positive, negative, 0, or undefined. So when looking from left to right, if a line increases from left to right, that has a positive slope. If a line decreases from left to right, that has a negative slope. A horizontal line has a slope of 0. If you think about rise over run, rise is a change in a vertical distance. So from point to point on this line, how much are you going up or down? You're not at all. And then running, going from left to right, that's just some amount from point to point. It's going to be different. Any fraction when the numerator is 0 is always equal to 0. Okay? Alternatively, a vertical line has an undefined slope. So if you think about rise over run, rise, the up and down change, is going to be some number. The run is 0, left to right, you're not going anywhere on that line. You cannot have a fraction with a denominator of 0. That fraction is undefined. Okay, so a vertical line has an undefined slope and a horizontal line has a slope of 0. Let's look at some examples on the next page. All right, so I will refresh our memories on the slope formula over here. Change in y over change in x. You might sometimes see that written like this, triangle y over triangle x. That triangle in Greek is delta, so change in y over change in x. Delta is the symbol for a change. Okay, so if we call this x1 and y1, x2 and y2, the slope is going to be change in y. If I start with 3 minus 1, on the bottom I'll do -4 minus -2. 3 minus 1 is 2. 4 minus -2, that's really -4 plus 2, so that's -2. This is a slope of -1. If you do it the other way, and you start with your y coordinate of 1 and then subtract 3, and your x coordinate -2, subtract -4, 1 minus 3 is -2. -2 minus -4, that's -2 plus 4, which is +2, and that also reduces to -1. So regardless of which y coordinate you start with, as long as you follow the correct process in the formula, you're going to get the same answer. Okay, looking at the next example, change in y over change in x, 3 minus -2 over 8 minus 6. 3 minus -2 is a +5 over 2. Okay, if you do it the other way, just for those of you who might have set it up the other way, -2 minus 3 over 6 minus 8. That's -5 over -2, and a negative over a negative is a positive. Okay, and looking at this last example, change in y over change in x, 2 minus 2 is 0, that's over -11. If you do it the other way, 2 minus 2 over 5 minus -6, that's 0 over 11. Any fraction, when the numerator is equal to 0, the fraction is equal to 0. So here the slope is 0. And that should make sense, because if you look at these coordinates, you might not have noticed it right away, but that's okay. If you look at these coordinates, both of those points have a y coordinate of 2. So that means this is a horizontal line. If you were to graph 5, 2, and -6, 2, and connect those 2 points, you're going to have a horizontal line, and every point along that line has a y coordinate of 2. The slope is 0. Okay, in problem number 2, we are finding the value of r, that's this y coordinate in one of the points, so that the line that passes through these 2 points has a slope of 5. So if I was just given these 2 points, the slope would be 3 minus r, or r minus 3, over -8 minus -4. If you did r minus 3, it'd be -4 minus -8. And this is 3 minus r over -4. Okay, that's the slope of this line. If I need the slope to be -5, then I'm going to set that fraction, that ratio, equal to -5. And to solve this, you're going to multiply both sides by -4. That cancels the -4 in this fraction. And you're left with 3 minus r equals +20. If you subtract 3 from both sides, that tells you that -r is equal to 17. So r is equal to -17. Okay, looking at this next example, we have in 2004, 5,545 women participating in collegiate lacrosse. In 2008, that number goes up to 6,830. So if we want to find the annual rate of change from 2004 to 2008, we are going to find the change in participants, or the change in number of participants, over the change in years. Okay, so the change in the number of participants we're going to get by doing 6,830 minus 5,545. Change in years is 2008 minus 2004. We know that's 4, but we can just set it up this way. Then you're going to grab your calculator. 6,830 minus 5,545 is 1,285 divided by 4 is 321.25. So this is the increase in women participating per year. So each year, an additional 321.25 women participate in collegiate lacrosse. And then finally, in this last example, what's the slope of the graphed line? So you can either figure out what the points are. So this point is negative 5, 8. And this point is 5, 4. And use the slope formula to find the slope between those 2 points. Or you can figure out what is the rise between these 2 points and what is the run. So from this coordinate of negative 5 over to this coordinate of 5, that is a run of 10, and to the right is positive. And from this y coordinate of 8 down to this y coordinate of 4, that is a rise of negative 4. Okay, so when you're going down from left to right, that's negative. So slope here is rise over run. Rise is negative 4, run is positive 10, so this is negative 2/5. And it should make sense that the slope is negative because when you look from left to right, that line is decreasing. If you prefer to do the algebra instead of the visual of that, slope here is going to be 8 minus 4 over negative 5 minus 5. 8 minus 4 is 4 over negative 5 minus 5 is negative 10. And that reduces to that same 2/5. Okay, go do some practice.